half hour. The last two things I want to cover, we're going to dig into 7.7, natural gas. And I think we mentioned last time, natural gas frequently is a nuisance at the oil head because it's flammable, it's heavy, it's coming out, let's just flare it. But you can see that it's become a commodity. So with the North Sea natural gas discoveries in the 90s, it became a big source of electricity generation. Domestic, what's that? Well, that's just cooking your food in the morning and keeping your shower warm. Industry as well, other services, and then energy industries. But big surge in electricity generation. And I don't know if it used to be illegal or not to use gas as a power source, but as you can see, it's something that's happening. There's a big push now in Montana to move to natural gas because it's sort of easier to switch those plants on and off, much easier than the coal-fired power plants. Okay, how do you get it from one place to another? You put it in a pipe underground, send it with a little bit of pressure. Gas storage is also mentioned here, and I think we soon will start to see more natural gas powered vehicles in North America. I was just on the train here between Montana and Michigan a month or so ago, and just on the phone having a conversation with some other energy colleagues, and there was this really interesting Danish engineer on the train. He said, "Oh, I couldn't help but overhear your conversation. There's a coalition to put in a so-called clean air corridor between Montana and Michigan." And the idea there would be that you're relying more on trains, electrification of the transportation grid, and also using cleaner burning fuels like natural gas. So
trains are the most efficient way of transporting them.
Trains really are. Yeah, very low rolling resistance, very high passenger density. You're not stopping and starting that much. Yeah. Yeah, very efficient.
Bicycle's like number 2 for efficiency.
Yeah, bicycles up there pretty high as well. There's a lot of ways to calculate that as well. Okay, so there's your gas grid. I think there's another pretty cool picture of the international gas grid as well. All right, so condensing gas boiler. We talked about the higher heating value earlier. This is how you get the HHV. Anytime you see someone put in a new boiler system in their house, typically the exhaust gas, it's tiny. It's small because a lot of you're allowing, again, that water vapor. We already did the stoichiometry. That H2O comes back and it just stays in the house. It just stays in the house. So it's just it's more efficient. In general. So that's sort of a much better version of the drawing I was trying to make earlier. So you still have combustion going on, still have air coming in, the fan is blowing this throughout the house, but there's a tube there that allows, and this is very similar to the refineries, where again once that gas is on its way out, it comes back and remains in the house, more efficient. Okay, we looked at oil distribution. Here's gas distribution, natural gas reserves. Still, lots in the Middle East, as we saw in the very first figure of the chapter. Oil and gas hand in hand. North America has proven reserves of 5%, and as we well know, we are going gangbusters right now to produce it. Europe, relatively modest reserves, but also producing. Soviet Union seems to be on or former Soviet Union, just those properties seem to be on a more or less of a steady state, as does Africa, with the Middle East having a tremendous amount of reserves and not producing. So, and again, table 7.6 does that same RP ratio. Qatar with an RP ratio of 284 years, the US at 12 years, the UK at 5, and those are just based on proven reserves. Okay, liquid natural gas tanker, Arctic Princess, stocks at the Grain LNG terminal in Kent. This is in the UK. Insulated tanks at the terminal. A lot of this was going on also after the Fukushima accident. A lot of natural gas going to Japan to keep their lights on. Okay, here's the grid. Natural gas grid. A lot of times you'll hear debates as to whether we should do geoengineering or not. I think we have. I mean, you look, we've engineered a pretty impressive array of energy distribution networks. The blue are existing. You can see there's these plans under construction to go, straight from Africa into Europe. Other ones undersea up there as well.
Is it more expensive if you lived in like the middle of like one of those blue squares, really? Like just It's so for every, so you can see the arrows, and this is where the gas is flowing from. And so if the gas is flowing in this direction, the money is flowing in the other direction. Yeah. That's how it works. With plenty of middlemen in the middle, brokering, buying, selling, building. Natural gas fields are listed. They're not all that easy to see, but here's a few. You can see these are actually stations where it's being produced. So someone's getting paid to go out there and man that station, turn the drill, turn the valves on and off, and then send it around on the pipelines. And so, it's coming from locations where the population density is relatively low, Africa being an example, Siberia, to where the population is relatively high. I think eventually it would be fantastic if we saw some of these converted into CO2 pipelines, and that allows your greenhouse facilities to pop up, right? So your CH4 comes in, your CO2 goes out. Where does it go? Well, it goes up into someone's fantastic greenhouse array that they built. And, let it sit in the greenhouse at 1,000, 1,300 ppms, and then you've sort of accelerated that growth. So I'd love to see that happen in Missoula too. Even just take our own existing sewer system and piggyback a CO2 distribution network on it. I think that'd be really cool. Yeah, I think it'd be great. Okay, and then this is good question there regarding supply and demand. So again, this is you find the first well, figure out how much is there, drill a little deeper. Eventually, it plateaus, it declines. At some point, you're putting more time and effort in than it's worth, and you reach the so-called economic limit. There's a really good talk on NPR the other day in terms of like who sets the price of gas, who sets the price of oil. Well, it's the consumer, but it's also the one person out there who's trying to make up his mind whether or not to keep drilling or not. And if he's willing to go for it and put his expensive oil or gas out on the system, then that's kind of the person that's doing it. I know, like a guy from Canada, he comes down and he's pretty much that guy.
Yeah.
In his field.
Yeah.
He doesn't like fracking.
Right. So if he's willing to put that one extra barrel or quad out there on the limit, that's the person who's setting the price. And then there's not enough. Price goes up. Now all of a sudden it's economically viable for him to go after it again. Yeah. All right. So here's oil production, gas production.
Now we're looking, this is UK. Actually, I want to hop ahead a couple, because now we're starting to get into peak oil. And actually, I'm going to skip a few other things here. Yeah, this is what I want to show you. So I'm actually going to skip pretty far ahead in the book. Very old school natural gas powered car. Other refineries, some other interesting engines. And then this again is where we might be eventually. I mentioned carbon sequestration. I think it'd be much better just to put that back into the biosphere through plants. You can see there's also, I don't know if they've got it here, Fisher trope. Some of this stuff actually heads out into crops, into fertilizers. If there's excess hydrogen, we might see a hydrogen economy come online. Former dean of Missoula College was actually trying to get that started in Missoula about a decade ago. Along with the Toyotas and the Hondas and the Schwarzeneggers, never quite took off, but we will be there eventually. I think we'll see. But anyway, where I want to get is to this guy. So this is Hubert. He was working for a big oil company back in the day as an engineer. Geophysicist M. King Hubert, figure 7.3, chose to present a rather gloomy paper to the American Petroleum Institute in Texas. This was in 1956. And the gloomy paper was this. He said most things in nature tend to follow a bell curve. This is the same curve that we looked at the first day of class. And there's your 1875. In general, again, things follow a bell curve. Here's cheap oil. Here's big cars, and now kind of here we are on the downslide globally. And maybe it's 150 billion barrels, maybe it's 200, but eventually this time is going to come. And in general, that's sort of played out based on the curve to the right. So this is what actually happened. So this was Hubert's prediction, and this was reality, just pure data. So Hubert in 56 is a little bit like the climate scientists of today. Like, okay, this is the model. This is what happens if you put greenhouse gases into the atmosphere, and time will tell whether they are correct or not. The next little section, just right after this figure, it says first the USA, now the world. So you could take these curves and do this for the entire planet. So we can start Titusville, 1865. And North American oil did something like this. It peaked in the 1973 or so. And we've just sort of been on the downslide. You can do the same thing for the Soviet Union, USSR. I don't know exactly what their production curve looked like, but they peaked right around 1989. So again, something like this, etc. The book also mentioned that the Middle East, started coming online 1900 something, and we don't know when they'll peak, but has it happened yet or not? You then just take all these curves, sum them up, and you end up with this global Hubert curve. So that's the whole point of taking each one of these regions And so, where's Venezuela? They're in here somewhere. Where's Africa? They're in somewhere. But you add all these curves up, and they end up being one big bell curve or Gaussian. Okay, so that's the whole concept of peak oil. The question, not to jump too far ahead, but the question might be, and let's just kind of look at it from this standpoint, because there have been other predictions that we'll never run out of oil. It's just carbon and hydrogen, right? So let's just take one brief peek into what that might look like. So let's just say, here we are in the 1800s to 2000s. So let's just look over that 200-year century, and basically what's happening on Earth. Here's your kind of oil reserve under the surface, and it's coming out into various products. We just looked at a bunch of them. Some are plastics, tars, et cetera, but it's CXHX. Now, there are a lot of interesting carbon sequestration things already starting to happen. You can also see, again, here's your CO2 being pumped off into the atmosphere. Also, there's in Hawaii, there's observatory showing that global oxygen is actually diminishing. There's just less oxygen per parts per million. Got a pretty neat gadget back in my office that will actually measure that. But what if we're able to, in the next, let's just say, let's just go 2000 to 2200. What if the next couple of years we're actually able to sort of reverse this trend, if you will, take the CO2 back in. There's lots of ways, forests, algae, et cetera. Take that back in, and instead, end up with, just biofuels. So you might argue, well, the natural gas, the oil, the coal, these are biofuels, just really old biology. But eventually you come up and say, no, let's go, and I'm just going to try to draw some plants here. Sorry, they're not green. But here's your sort of bio. The carbon goes back into the plants. The oxygen comes back out for us to breathe, and we still have the CXHX, and I'm just going to put a B for bio. And that is where we will be eventually. And then what happens, these curves, these sort of doomsday curves, just sort of flatten out. And when we get more into a equilibrium scenario, maybe this hydrogen economy comes online, where you sort of just take carbon out of the equation, because if we look, if we go back to our energy density, look at hydrogen out there. Super energy dense. Very flammable, not that easy to deal with. If you want, at some point this semester, we'll do a field trip over to what's going to be the new Missoula International School. I have our hydrogen fueling station over there. It's just sitting over there. It's a 25 kilowatt electrolyzer, tanks. I've got Kevlar lined cylinders that'll hit 300 atmospheres. It used to be sitting over where the new Missoula College building is, and so we're looking for a new home for it. I had some folks from California come in and say they are trying to revive the hydrogen economy on the I-5 and I-15 corridor, and we thought, well, maybe we'll have our own little lone station out here. When the Toyotas and the Hondas and the Mitsubishis show up with their fuel cell vehicles, we can be here to fuel them. So we do have that technology, but there it is, sitting out on the horizon. Okay, what else do we have to do in this chapter? Those are the main things I really wanted to cover. Just get to peak oil, oil shale. Again, kind of, sitting out there as a possibility. There's, still carbon to be had in the deep depths. Yeah. So there's kind of, looking out into the future, but more or less showing that crude oil, the good old days of crude oil will dwindle eventually. Well, it's just reality. It's just where we live. We're just living in a.
The balloon popped.
Yeah, but again, the carbon atoms themselves aren't going anywhere. And they do a great job of mixing with oxygen to create heat and motive power, as we well know from the earlier chapters here. So, all right, that's all I have for today. When I see you next week, we'll start looking into oil and gas engines. So, using these fuels for combustion, and then looking at the power that comes out. So we'll look a little bit at the technology. We will talk catalytic converters too. That'll be fun.
I was really getting into those today.
Yeah, no, it's there. Me too. It's good stuff.
Thanks, Brad. Have a good week.
Okay, see you, Tyler.
Have a good weekend.
Okay.
See you.
Yep. Is it Mosey?
Mosey, yeah.
Mosey, okay, yeah.
Yeah, it's John Gerber on there.
That's cool, yeah.
Mosey.
I used to have a software backup tool called Mosey.
Really?
Yeah.
I hear it, yeah, randomly. Like, some people will be like, oh, I've never heard that before, and then other people will be like, oh.
Well, I'm not sure I know any other people named Mosey, but
Some
name.
person, there's this, like, app called Snapchat, and